Today Ai is showing us her new shoe collection. This is Rose and Chaos. It's a new design. And it's nicely resting on the table. This is No Pain. It's hung from a construction winch. And no one knows why. But it's also in an equilibrium state. This is Geo Sky Shoe. This heel-less geometry is also resting on the circular table. It's also in an equilibrium state. Now we come to the crazy one. Infinity. This shoe is floating in space. And this is impossible. So, either Ai made some magic with it, or it should fall to the ground. Although all of us know that it should fall. But some of us don't know why. The reason is gravity. It is what pushes infinity toward the ground. Gravity is a gradient field that surrounds our planet Earth. Anything comes within its range, it will accelerate toward the center of Earth. Gravity does not care about the size or mass of objects. All objects with have the same acceleration. Now consider this small ring that Ai is holding between her fingers. We now know that gravity is trying to push it down by applying a push force. Notice that the direction of this push force is going downward toward the ground. But as Ai is holding the ring, then her fingers will create an upward forces that oppose the direction of gravity force. And this what keeps the ring from falling to the ground. But the moment Ai releases the ring, these forces are no longer exist, leaving the gravity force only acting on the ring. So the ring will fall to the ground. And during its fall, the ring's speed will increase downward, which means that the ring is gaining an acceleration. Before we proceed, let's have a quick reminder of vectors. We know that velocity is a vector quantity. So it can be represented by an arrow. And the length of this arrow represents the magnitude of this velocity, while the direction of the arrow represents the direction of the velocity. Now look at this golf ball resting on the table. The ball has been given an initial speed, so it traveled upward. The speed was initially maximum, and then started to decrease as the ball moved up. Look at the length of the arrows, how they decreased their length on traveling upward. And this is because gravity is trying to push the ball back to the ground. So it decreases its speed gradually. When the ball reached the maximum height, its speed will become momentarily zero. Then the ball falls down back to the ground, starting from zero velocity, and then increasing its velocity downward. Look at the arrows, how they increase their length on the way down. And again, this is because gravity is accelerating the ball toward the ground. Now let's consider the golf ball again. But this time, The ball is at 1 meter height from the ground, and it will be released with zero initial speed, so it's freely falling due to the gravity. Using some accurate timer, the time from the moment of release until the ball touched the ground was measured as 0.4 seconds, which is less than a half second. Now, employing some linear motion equations, we can calculate the acceleration that the ball gained during its fall, and it was around 9.8 meter per second squared. This values was found the same for all objects acting under free falling regardless of their masses, and this value was given the name gravitational acceleration. Now we can modify the three equations of motion by replacing the acceleration a with negative g. So now we have the three equations of free falling. In the next videos, we will discuss some real-life examples of free falling bodies. Thank you for watching.